We can use the Pythagorean theorem for examples like this. So if you have a pole that is perpendicular to the ground, that just means that there's a 90-degree angle there between the ground and the pole. Then you have guy wires that are bracing the pole on either side that are attached at the top of the pole. If you know that each guy wire is 25 feet long and that the pole is 20 feet high, we want to know how far are the grounded ends of the guy wires from each other. So here, we're looking for this distance AD. Now, right now, we only have the skills to get from A to C and from D to C because we have simply a right triangle. So here, we have the right triangle on the left, and then we can do a right triangle on the right. And then, when we get those two sides down at the bottom, then we can add them together to get the full length. So let's do the side AC, and I'm going to call that X, and then later we'll get CD and we'll call that Y. So looking at the triangle on the left, here we know that X squared plus the other leg, 20 squared, equals the hypotenuse of 25 squared. In this case, the guy wire is serving as the hypotenuse. So we get 20 squared is 400, 25 squared is 625. Now if we subtract 400 from both sides, we get 225, and the square root of that gives us 15. Now we really don't have to do this again for Y because it's the exact same triangle. You still have a leg of 20 and a hypotenuse of 25, but if you wanted to, do it again, because this will not always be the case. We won't always have these two lengths being the same. So if you needed to split it up doing two triangles, you could. Y squared plus the other leg squared equals 25 squared. But in this case, we will have the exact same numbers. And so y squared equals 225. And our y is going to also be 15. But the answer to the question, how far are the grounded ends from each other, we need to add x plus y and get a final answer of 30 feet. Here we have an example of a jet that is traveling 7.5 kilometers. And so that's going to be the air distance while gaining altitude at a constant rate. If it travels between horizontal points that are 5.8 kilometers apart, what is the gain in altitude? So think about the airplane traveling in that direction. It's going to be at some angle up into the air. And then you have your altitude. That'll be the distance from the plane down to the ground at a perpendicular angle. And we know that the 2 points from where the train starts, where the jet starts, and where we're measuring this altitude is 5.80 kilometers. And we're given that the jet is traveling 7.5 kilometers. And you would measure that distance based on the actual distance traveled by the jet. So we want to find the altitude, and in this case, that is a side. So we can do side squared plus side squared equals hypotenuse squared. And I'm just leaving off the extra 0 there at the end. So here, a squared plus 33.64 equals 56.25. We'll subtract 33.64 from both sides. And so a squared equals 22.61. Now we take the square root of both sides. That's always the last step on these Pythagorean theorem problems. And we get 4.75, which would round to about 4.8 kilometers in altitude. Another example here is looking at a surveyor who's trying to get the distance between 2 points, but there's a building in the way. Well, what they could do instead is create a right triangle where you have formed an angle at C that is at a right angle to point A and to point B. you can measure those because there's no obstructions. Those would both be sides because they are next to that 90-degree angle. So these would be legs, we can call A or B, and we can find what we're interested in, the distance between A and B, by solving for a hypotenuse. So let's do that. 103 squared plus 192 squared equals our unknown c squared. These are some larger numbers. So if we add those together, we get 47,473, and take the square root of both sides, and we're getting about 218 meters. Depending on how specific you need it to be, you might go 217.9 or even 217.88. And then the last example here, we have a cable that's attached to the top of a 22-foot pole. There's a man holding a cable, and he moves a certain distance from the pole and notes that there are 30 feet of cable from the ground to the top of the pole. We don't know how far the man traveled, however. If he moves another 10 feet, we want to see how long the cable would need to be to reach the ground at his feet there. So this is a compound problem that's going to have to be solved in a few steps. We're always looking for where we can form a right triangle. So if we form this right triangle with the triangle all the way to the right, where we have a side 22, a side that we don't know, but we do know the hypotenuse of 30, we can use Pythagorean theorem to find that missing side. I should have written an equal sign there. So we have 22 squared plus x squared equals 30 squared. So that's 484 plus x squared equals 900. Subtract 484. You get 416. If you take the square root of that, we're looking at 20.4. Now, let's think about this larger triangle. So here, we're trying to find what length that would have to be. The pole is still 22 feet, but now we have to draw the entire triangle. It's tempting just to use that 10, but that 10 is not a length of the right triangle. So you have to actually go in and add that 20.4, that we just found. And so this overall length is actually 30.4. And so now we can do Pythagorean theorem again. 30.4 is a side, so we do 30.4 squared plus 22.0 squared equals this unknown y squared. And I'm going to go ahead and do that in one step in my calculator. 14.08.16. Take the square root of both sides. And we're looking at the wire needing to be, or the cable needing to be 37.5, and our units here are feet.